So the next presentation is about the Comfort project, which is one project that is funded under Horizon Europe, and it's about the development of computational models for the stratification of patients who suffer from urologic cancers. So Comfort aims to develop and prospectively validate multimodal AI-based decision support tools to improve the detection, diagnosis, and prognosis of patients with kidney cancer and prostate cancer. It is coordinated by the Charité University Hospital, and also as Aristotle University of Thessaloniki is partner who is responsible for evaluating in the clinical setting the algorithms that will be developed. Its duration is about 4 years. So the main objectives of the Comfort project is to develop transparent and accurate computational models by integrating complex multimodal health data, to utilize advanced AI-powered risk stratification methods in order to assist healthcare professionals in selecting the right treatments, preventing disease progression and improving the patient journey. Create AI trustworthiness models to detect and mitigate ethical concerns, increasing, of course, the trust of healthcare professionals and patients in AI in order to take more informed decisions. And finally, to conduct a multinational evaluation of AI models in clinical settings in order to be prepared for a future certification of the technology under the medical device regulation of EU. So what are the different data types that we are using in our project? So we are having imaging modalities like multiparametric MRI or CT scans, individual health records, so unstructured data coming from text, several biomarkers like PSA levels for prostate cancer or other relevant markers for kidney cancer, and also several demographic information and disease history about the patients. So what are the challenges in terms of data that we aim to tackle within the Comfort project? Actually, one key thing is we are talking about real-world data, so accessibility in that respect is of foremost importance. So in Comfort, we have access to about 5 or 6 hospitals across Europe with different information management systems. And of course, we need to perform homogeneous collection and annotation procedures in order to build our algorithms on top of this data. In order to handle the data sparsity problem as well, we plan to use techniques such as few or zero-shot learning. And then in order to analyze the multi-source data, we need to have also a homogeneous data representation, fuse them and analyze them all together. So in that respect, we aim to create several embedding techniques or using any existing state-of-the-art techniques. And also the other aspect that we face as a challenge is, of course, bias in data. So we plan to have several measures in order to identify the bias in the data and also try to debias the data sets before we include them in the training of the algorithms. So let me just emphasize again our approach in terms of data-driven AI tools development. So multimodal data are at the core of our analysis. Deep neural networks and natural language processing, including generative AI, will be explored during the project, and also a governance model on trustworthy and transparent AI for patient stratification is about to be developed, including, of course, techniques about explainable AI that will transform our approach as user-friendly to the healthcare professionals. So here you can see an overview of our approach in terms of multimodal AI modeling development. As I mentioned before, natural language processing will be at the core of our analysis, meaning that we have to process several unstructured text reports from radiology examinations, etc., but also having data from demographics, laboratory, and we aim to use several embedding techniques, as I mentioned before, like concatenation and so on. And the main pillars of our analysis is explainability, as I mentioned before, reliability, accuracy, and of course, to make meaningful and understandable outcomes for the clinicians. Here you can see just some first developments of our project. An open source tool has been developed and delivered and is publicly available at the moment. Of course, under development, as I mentioned before, and it needs also fine-tuning. It's called MR Segmentator, which performs segmentation of MRIs from the body. And here you can see some examples of what we have achieved so far and see some indicative case of a pathologic kidney cancer patient and how we achieve quite an accurate detection of the tumor and the kidney. So I want to close my presentation by just saying that we have performed two global surveys at a global scales. One is trying to reflect on the attitudes of the future doctors, so future healthcare professionals actually, including doctors, nurses, and other healthcare professionals of the future. So these are undergraduate students that we have performed a survey regarding their attitudes towards the use of AI in the clinical setting. What we can say from this survey and we can take as a home message, take-home message, is that we see a trend that healthcare professionals are interested more on the transparency of AI rather than just black box accurate algorithms that will perform like for 100%. So this is something that was emphasized and we got it as a message that transparency is also now a prerequisite for developing and using in the clinical setting AI algorithms. And the same, a similar study we have performed with patients across, not only just across Europe, but also across the world. So about 30,000 patients from 74 hospitals in 43 countries have answered in the different questions about their attitudes in artificial intelligence, where in general we see a positive attitude in having AI solutions supporting their care. And of course, when this has need to be implemented in the clinical practice, they believe that this will be the case in the future, and they highly support it, of course, taking into account security, privacy, and ethical dimensions of AI when implemented in their care. That's my presentation, and maybe we can move to the next one.